we're going to do now is take a look at a couple of the sapling problems that you are ready to solve already in homework 1. So the first question, it's got 3 different molecules and it's asking you to, it's giving you the Lewis structure and it's asking you to write them as a condensed structure. And if you went through the sapling tutorials, it shows you how to use the chemical formula typing stuff features in sapling. I wanted to talk a little bit about these 2 parts of the problem because they are a little bit trickier than the ones that we did in the notes. So when you're writing a condensed structure, remember your goal is to represent the actual shape or connection of the molecule. So you have, in this particular molecule, you have 3 chunks that you are going to represent. A CH3, that's your first chunk. And then this chunk in the middle has got a carbon with a hydrogen and an OH on it. When we've got a lot of stuff going on one of these chunks that we're writing in the condensed structure, our standard way of doing this is to write the carbon atom first, and then to write hydrogens that are directly attached to that carbon, which is just this one up here, and then to write the rest of the stuff, so OH. And so that's CHOH. That's how we would represent this particular segment in the molecule. And then last, that's easy. That's just a CH3. So this CHOH, we want to use that notation, not something like COHH or COH2 or something like that. Carbon first, hydrogen that is directly attached to that carbon, and then everything else. And for the last one down here, this one's easier than the one that we just did. Again, we're just looking at our chunks. So we've got a CH3, we've got a CH2, and then we have this oxygen all by itself, and then a CH3. A CH3, CH2, oxygen all by itself, CH3. So there's that. Let's see, for problem number 2, this one is kind of helping you get ready for or get practice with drawing line structures. So this problem, it's giving you a carbon skeleton. The first problem, it says C, 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 and it's just asking you to fill in, the missing hydrogens. So again, I totally recommend that you do the tutorials on how to draw structures in Sapling so that you know how to use this software. But what we're doing here is just editing the formula, or excuse me, the drawing to show the missing hydrogen atoms. And to do this, what we're doing, like we're going to look at the second carbon in the chain now. Just like I talked about in the lecture notes, how many bonds can we see? We can only see 2 bonds to that carbon, which means that it must have 2 more bonds that we can't see. And so we're just filling the molecule in like that. We can see the next carbon over, we can see it has 2 bonds. That means that it's got 2 bonds we can't see. So that's all you're doing for that one. Problem number 3, it has a line structure for you, and it wants you to fill in or use these little numbers to indicate how many hydrogens are on that carbon. So this is definitely practicing line structures. Like, let's do this one that I'm messing with on the bottom. For the carbon that's down here, we can see one of its bonds. We know that it has 4 bonds. We can only see 1, so that means it must have 3 hydrogens attached. Same with this carbon up here that I just put the 3 on. We can see one of its bonds, so we know that it must have 3 hydrogens attached. Now, for these carbons, the one that I just put a 0 by, these ones out here, the carbons that are part of this ring, sorry, it's kind of spazzing out when I move. All these carbons that I just put zeros by, we have double bonds. Now, remember that from 121, a double bond counts as two bonds. It is two bonds. So if we're looking at this carbon down here that I'm messing with, what can we see when we look at this carbon? We can see that it has one bond up, it has two bonds to the left, and one bond to the right. That's a total of 4 bonds. Because it has 4 bonds, that means we can see all 4 of its bonds. It has no hydrogens, so I was actually right by putting a 0 there. No hydrogens. For this guy over here that I'm messing with, how many bonds can we see? We can see 1 bond to the left, 2 bonds to the right. That's a total of 3. That means this guy has 1 hydrogen attached. We can see 3. It's missing 1. So you're going to fill in the rest of these. That 0 up there is probably wrong. Let's get rid of it. Fill the rest of those in. You should have no problem with that. Here's another line structure. Same type of thing for you to practice. How many bonds can you see? How many bonds must also be there that you can't see? Like, let's do, put a 0. Let's do this little guy right here. We can see 1 bond to the left, and we can see 2 bonds to the right. That's a total of 3 bonds that we can see. We know it wants to have 4 bonds, so that means there's a 1 hydrogen that belongs right there. And what do we have here? Okay, so here for this problem, we have a condensed structure up here at the top, CH3, CH2, CH2, CH3. And down here it wants us to draw, it says the complete structure. That means it wants us to draw a Lewis structure. It wants everything all drawn out. My biggest complaint about Sapling is that when you're drawing bonds, it defaults all of the bonds. It defaults all the bonds to carbon-carbon bonds. And so then you have to go in and change that carbon to a hydrogen. That's not that bad though. So for here, again, the complete structure, it's just asking you to draw the Lewis structure, showing all of the atoms and all of the bonds. And down here, now it wants you to draw the line bond, line angle, bond line, skeletal line structure. Just wants the line structure of CH3, CH2, CH2, CH3. And question number 6 is the same type of thing, but here you're just being given a larger molecule. So again, the complete structure, it wants the Lewis structure, and then for the skeletal structure, it wants the bond line structure.